Just to complete the introduction of Matthew, on this portal, we are also open to discuss with the Silva community if we can open source it. So it's something, if we see some interest, so please give us a feedback at the end of this meeting so we can go deeper with Laurent and Yannick's team on this topic.
Okay, thank you, Guillaume. And thank you for your interest and attention about Kunai. We are going to speak about Kunai, and Kunai for us is an API and a portal to match with the methodology of deployment used by Silva. So we called this tool Kunai for Kubernetes North API. We are four of us working on that. François Cliébert, who will do soon a demonstration. Frédéric Viau also is the developer. Me, Laurent Moinet, and Yannick Dubuc, my manager. And we are working in Orange for the IT part of Orange in Orange Innovation Department. So the presentation will last around 10 minutes, and for the generality, and after François take the lead for the demonstration through a video, not in live, because it's more secure to do that. Okay, it works. So an introduction. Kunai is for different population. We imagine it for integrators, but also operational team operations, and also vendors. And for which target? For Silva, obviously, Orange Telco Cloud, the equivalent of Silva in Orange. And for Diode, Diode is a program for Orange in IT part, so in IT context, not for network context. Kunai is a front end, like I told you. It's also APIs. You can use what you want. It's done for simplify the deployment of Silva workload clusters. We started around that in September 2023, so in the middle of last year. It's a prototype for the moment. We developed that with the Next.js framework. We provide Kunai as an end chart. It's based on the GitOps concepts like Silva. With Kunai, we can manage exactly like Silva RK2 clusters, but also, and we tested that in IT context for Diode GKE in Google. It should work also easily for EKS, so for Amazon. And we tested that in a specific usage for IT with vCluster. I don't know if you know this technology. And like that, we can manage the life cycle of different type of clusters. And it works in different infrastructure, OpenStack. Obviously, like Silva, also bare metal, and finally GCP, Amazon, and also another infrastructure of Orange called Cloud Avenue. It's based on VMware. The key point of Kunai, naturally, it's the GitOps topics. It must be GitOps ready. It's important. We don't change the methodology of Silva, and the forms of the Kunai portal are auto-generated from Git. So no intelligence in Kunai. All is on Git. Kunai is done to facilitate the Silva adoption. It's not necessary to know GitOps or cluster API. Like that, it's perfect to break the complexity of Silva. So, and it's related, the lifecycle management is simplified. And with Kunai, we can bring templates catalog based on the Silva values. Other key points for Kunai is the reproducibility. We are using the same model everywhere. It's done for the industrialization concerning the automation, because we bring APIs to let infra as code possible for customers. And it's done also to secure the deployment, limiting actions in the reference source, so in Git. So to make this prototype, we built a maquette in Orange infrastructure for integration, and it's based on OpenStack. And in this infrastructure, we installed Git. It's a GitLab, but it can also be GTA or GitHub. It works with all type of Git. Also, in this maquette, we installed management clusters based on the Silva principles. With inside this management cluster, all the controllers for cluster API. And we installed Flux to manage the GitOps flow. And like that, like in Silva, if a customer builds his workload definition, workload clusters definitions in Git, the Flux flows detect this modification in Git, and through a pull request, suggest this workload definition to cluster API in order to deploy and manage the workload clusters in OpenStack, but also it can be done in AWS, bare metal, and so on. So based on these principles, we implemented Kunai in order to replace the work of the customer inside Git and do the same work through the API or the portal. And it's more easy for the customers like that. So through the CRUD methodology, Kunai will do the modification in the Git, and based on the same principle, the deployment will be done. And also through the Kunai, we can have the status of this deployment, getting the status through the management cluster. And in addition, for Orange network, innovation network, we are testing the implementation of Kunai inside a specific tool called OTC Self-Care, done to manage the infrastructure, the integration infrastructures in France and other countries. So we will implement Kunai through the API usages directly inside OTC Self-Care portal. So you have the roadmap started with Innovation Network. So this integration in OTC Toolbox or Self-Care, because the name can change again. We have the first user feedbacks quickly with this implementation, and we will be able to think the operational model of Kunai inside OTC Toolbox or Self-Care in order to, in the third quarter, run this operational model and have the first feedback of countries when it will be used. And maybe we'll work also of another integration of Netbox with Kunai. We'll see that. In parallel, we are studying the possibility to manage the drift inside Kunai between the reality and the Git without an automatic reconciliation. So it's a need from Orange Innovation to stop the GitOps automations, in fact, and let the control to the operators. And we'll test also the deployment of bare metal in countries. So that's it for me. I can let the show to François in order to do the demonstration. Are you ready, François?
Yes, thanks, Florent. So the demonstration will be in 3 steps. The first, we are going to deploy a cluster using the web interface. Then we will do the same using the API. And last, I will show how we can add the template in the catalog of Kunai. So we can jump to the video. So here we can see Kunai on the left, and on the right, we will see what happened in the background. So first we log in the application using Kunai, using Keycloak. Keycloak is the authentication component. Here we have the referential. Referential can be seen as a set of values that has been approved by administrators and represents the catalog that we offer right now to our user. In this folder, we can see how it is structured. So base represents the main component that can be reused everywhere, and we have some folder for each provider, so for Capo, OpenStack, and also bare metal. In the template, we have the template that we already provide. So for MetaCube and also OpenStack, we have a different one for development and production purposes. Templates are only configuration file. So if we need to deploy a new version, we don't need to create a new Kunai. In fact, we just need to update the configuration file. So now we are going to add a project. We only need to add this project once, and then all the lifecycle of the cluster will be done using Git. So in this demonstration, I will show how we can create a new project on GitLab and how we are going to attach this newly created repository on Kunai. So the URL will be the direct URL of the Git repository, and we are going to create also an access token in order to allow Kunai to use this Git repository. So it needs to have the role of maintainer and read and write with the access to the repository. Then we set the URL of the management cluster with a token associated to this management cluster. Now we can see the status of our management cluster, and we can see that it is we have a healthy management cluster. So we can now create some workloads. We see that in the background, our newly created Git repository has been initialized using the reference that we have set to Kunai. And now we directly have item in our catalog. So for the purpose of this demonstration, we are going to deploy an OpenStack production cluster. So basically it means that I will create 3 control planes with at least 3 workers. So I give a name to this cluster, and now I'm going to retrieve in OpenStack the ID that I need to have in order to create this cluster. So first, I'm taking the ID of the network on which I want my virtual machine to be created. And I also provide the ID of the external network. This ID is to have my floating IP, so my created cluster can be reached from outside. And I'm selecting the path on Vault where I've set my credential. So first, we have created the configuration file in the Git repository. We can still edit this, but it is not deployed or reconciled using FluxCD. So in the background, all the GitOps workflow is done using Flux. This is the magic of the video. We can see 20 minutes later. The workload cluster is now created and up and running. If we check on OpenStack, on the right, we can see that we have now 6 new virtual machines that represent our newly created cluster. I'm going also on the right to show you what was the file or configuration file that has been added to the Git repository. And as I've also deployed Rancher on the management cluster, our newly created cluster is reachable from Rancher. Now we can update our cluster directly using Kunai. Here I am adding a new worker to the cluster. We only need to wait approximately 4 minutes before our newly machine join the cluster. And if we go back on Rancher, we can see that our cluster is now having 7 nodes. So now I will show how we can create a cluster, but this time using the API. So on the left, we have Kunai, and on the right, we have an example of API usage. So we are posting a JSON that represents our cluster with the value on Kunai. So the first step is to create the configuration file, and the second one is to deploy it. So now if I refresh on the right the page and the Git repository, I can see that I have access to this configuration file of the demo API. And if on the left now I have waited enough, I can see that my cluster is being reconciled. And also on the right, we can see that the instance is being created. So if after waiting approximately 15 minutes, it's the time that it takes for a cluster with only 1 node to be up and running. I can see that I have access to this cluster using Rancher, and also so everything is available on OpenStack. Now I will show how we can add a new template on Kunai. So as I told, a template is only a set of configuration file that has been pre-approved by our administrator. So it's all the configuration files that are required. So for the secret, I'm using external secret. That is everything is deployed in the Silva management cluster. The form and all of these fields are stored in a YAML format using JSON form. In this example, I've added the Kubernetes version that we are going to use. And the last file is in fact the value template, and it is how we can implement this Kubernetes version in the value file. So here is how we can hide the complexity of Silva knowledge so between the field that we enter in the formula and where it should be placed in the Silva values file for it to be working. And now on the left, I can directly use the newly created template, and I have access to this Kubernetes version in the template. So this ends the presentation. Since this video, we have also enhanced the Kunai interface. Now all the API are also exposed to the developers using Swagger. And we are trying to also provide more feedback in the UI to the status of the workload cluster. This is all for me. Thanks for your attention. And we are here for all your questions.
Thank you, Laurent. Thank you, François. Any question?